graphs of functions. Yeah, maybe, does that make sense? No, probably not. Awesome, so we're moving away from the transformations for a second. Just a small second. And we're going to start we're going to take this function, we're going to graph the function, and then we're going to graph what the root of that function would look like. Super easy. Yeah. Okay. Can you guys graph this? No. Yes. Okay. What is this, ladies and gentlemen?
It's a regular linear.
It's a regular linear. It's grade 10. You're graphing a straight line.
Yeah, slope and all.
Slope and all.
Great.
Do you want a table of values? Would that go? Okay, okay, if I rearrange this to f of x equals negative 2x plus 3, for me it's easier to see this way. What is the 3? y-intercept. So it's going to cross at positive 3. And then what's my slope? Negative 2 over 1, so what does that mean? Down to right 1. So down to right 1. This is exciting, isn't it? Now, I want to continue my line past my y-intercept. How do I do that? Up to left. Is this coming back to you guys? I got a surprise for you guys that you're going to be super pumped to get. We call it a house treat.
How do you keep on going?
Okay, can you guys do? Okay, so linear equations you guys are solid on. If I asked any of you in this classroom right now to give me the distance formula with what the distance formula is without your phones or old formula sheets, could you do it? Yes. Almost. You're kind of that's a slope. Okay, so we're close. You go first. All right. Okay, let's do the radical of this graph. So what are we really radicalizing? I'm doing the root of this graph. So really I'm doing y equals the root of 3 minus 2x. Does that make sense? Because the function is what we're actually rooting.
So after that rearranging that this is actually part of the x and y.
The 3 is part of the x. What? Say what?
Yeah, like in the original, on the original formula, you can't use the new formula, the rearranged formula, right?
Oh, you could. I just wrote it so there was no negatives.
But I thought if it's
This is the exact same thing.
okay. I thought the 3 was outside.
No, the 3 is not outside because this is the function, is this whole thing, and we're taking the root of that function.
Oh, I see. Yeah.
Okay? So here's the dealio. f of x, what else can we call it? Y. So what are we going to be square rooting on our table of values? Just the y values, not the x values. So my x values, negative 2, negative 1, 0, 1, 2. Whew, that was good. So now we're going to square root some stuff. Root 7. We're just going to leave it as root 7. Root 5. Root 3. 1. What about this one?
It can't.
So,
Like an answer. Is that fine?
It's not undefined, it's actually an imaginary number at that point, the square root of -1. No possible, not possible. Alright, look, okay, I've got an overbite today, I'm speaking different languages, it's no possible. Alright, so can we graph these? You're probably going to need your calculator unless you can use square roots in your head. Oh, yeah, I have 3.5. So this one is approximately, okay, so 2.7. What's the root of 5? 2.2. 2.2, what about the root of 3?
Oh, looks like 1.2, so 1.7.
1.7. Okay, so 1, 1. I got that one. What is it? Invariant point. It's a point that doesn't change.
I just don't understand like that, do they have a terminology question?
No, they will just say like, what's the invariant point to this graph?
Okay.
So they'll expect you to know how to graph, and you need the graph to identify what the invariant point is. You know what I'm saying?
Yes.
They would say define an invariant point.
Okay.
Okay, so then at 0, I'm at 1.7. And at -1, I'm at 2.2. And then at -2, I am at 2.27. Where did I remember here? 2.6. 2.6. Okay. So imagine that it goes, it's a line of estimate. Imagine that it goes through all of those points.
Is this supposed to be straight?
No, it's supposed to, remember that all graphs are curved. Radical. And you're starting to look like mine, that's never a good thing when you guys have worse graphs or like my graph. So, we're missing a point though.
Not possible.
It's not possible. No possible. Okay. I got some problem. This is my table of values, which we were solid on, and worked super well for my green graph. But we're missing a very important point. Would my graph start at, or no points, I guess my question would be between 0 and 1?
Yes.
Would there be no points between 1 and 2?
Yes. There are.
There are points, and chances are they were. They just weren't in our whole value there. So this is the key point. You need to find, what would I need to find?
Lowest possible.
Yeah. Where would that be? What's the lowest possible value a root can be? 0. So what would I be solving for?
No, for one where y was 0.
Where y equals 0. Right? So we would be solving for the x-intercept, right? Because the x-intercept is where y equals 0. Does that make sense to everybody what we just did there? Okay, so we're going to go back to our original thing. So 0 is equal to 3 minus 2x. So x is equal to 3 over 2, which is 1/2, right? So we know on this original graph at 1.5, y is 0. Yes? You guys agree with me? So wouldn't that point be located on here as well? Yeah, because we have 1.5, and what's the root of 0? 0. So my graph actually doesn't start at 1, 1. There. 1, 1, where does it start? 1.5, 0. Does that make sense? If you had your graph only starting at 1, 1, you're getting an incomplete situation. So here's the key to these. Always find your x-intercept of your original function. It may not be a pretty number, but it's still where your radical graph is going to start. Yes? Good? Hope so. So where would my invariant points be?
1.5, 0,
Okay, so you will always have invariant points when f of x is equal to 0 and f of x, standing right in front of this, is equal to 1. How come?
The square root of 1 is 1, so it's
Any other numbers would that work for?
no.
No. These are the only two numbers that the square root is the exact same as the original radicand. You guys remember what radicand is? That's the number under the root sign. And the index is what kind of root it is. Everybody okay with that? So you will always have invariant points here when y values are 0 and y values are 1. Okay. Oh, really? I really need to like write smaller or maybe pay attention to the question. Okay, let's do the domain and range. I'm running out of room. Domain range of the original function f of x. So the line. Both. Negative infinity, positive infinity. Range? Negative infinity, positive infinity. Do you feel smarter now? So what would be the domain and range of the radical graph? So the domain is going to be negative. That's an infinity sign today. To positive 1.5. See why that's important as well, finding that or the x-intercept? Because it becomes part of your domain. What about the range?
Did you use the square bracket for that?
Oh, I would. 0 to positive infinity. Would you believe me if I said that one was a square bracket? What? Would you believe that that was a square bracket?
No.
No, but you guys make me try to believe it all the time. Okay, look at it right here. Relative locations. The domain of the root of f of x consists only with the values in the domain of f of x, where f of x values are equal to 0, or greater or equal to 0. Make sense? Yeah, it does. It does. Can we have values where the f of x graph is less than 0? No possible. No possibles, okay? So that's all that's saying, is that the only place that you can have a domain is where the y values are greater or equal to 0 on the original graph. Because if they're negative, no possibles. The range consists of square roots of the value y equals f of x, where which f of x is defined. That negative square root would be where the undefined place on the graph would occur. We wouldn't have points there. It means the same thing, essentially, but your graph is only going to exist where the original graph has positive y values, or 0. Some of us have negative zeros, whatever. Okay, this would be handy. No, let's do this by hand. if you guys graph this, what is this gonna be? It's gonna be a parabola. But, okay, we know some stuff. Okay, so you should see my notes on this. I don't know if you guys can see all the graphs. Like, it's pretty messy, but this is what I do for funsies. Y equals negative 0.5 x squared plus 2. So from this information, I should be able to do a graph. Can you do that? Grade 11, coming back to haunt you? What's the y-intercept? What's the vertex? 0, 2. That would be my vertex. It would also happen to be my y-intercept. Right? Because if I put 0 in here, that just is a 2. And what way is the graph over? Down. So let's just do a rough sketch. What kind of, is this going to be wider, wider, or narrower than an x squared graph? It's going to be wider.
Because how many frames of that's two?
Alright, you just recycle your kills, like,
It's not. It's not.
That's true. Okay, well, let's, okay. Could you guys find the zeros of the function for me? Yes, you can. The reason, yes, because you know what, we're not so good at factoring, and we're not so good at using the quadratic formula, so it's a great time to practice it. Do you know the quadratic formula right off the top of your head? X equals negative b. Got it? You got it all? X equals negative b plus or minus square root of b squared minus 4ac, and the whole thing is over 2a.
In this case, E equals 0.
B would equal 0. You just factored it, you crazy. What did you do?
I hit it all buttons.
I have to sit it against the metal. Okay, where are my zeros? Could you guys have factored it faster? Could you have solved it faster? Yeah.
No, I saw that.
Yeah, you didn't factor it, you solved it.
Your problem?
2 and negative 2. You got it, Maya. Well, so this is 2 and 0 and negative 2 and 0. Hey, the expectation is you can do that in your sleep.
I don't even know what they just did.
They use the quadratic formula to solve for the zeros of the function. Oh, no. No, if I'm gonna put a muzzle on.
I don't know. They can make all
Yeah.
those people.
You ever see Silence of the Lambs? You might like it. Hannibal Lecter.
Chase. That's not really good.
And just saying.
You're not just saying.
Would you
Not-
say? No. Oh. And we're lost. Okay, can we go back to this for a second because I'm traumatized. While we're here, let's do the domain and range of this graph. Domain of this graph. I don't know, like, you wrap it up and then you can find it there if you want. Hey, please stop. Please stop.
What is the exact?
Yes, we are still recording. Why would we miss this wonderful education? educational experience on anything else. The poor souls who are not here today will be listening. Okay, range for this one.
Negative infinity to 2.
Yeah. Negative infinity to 2 square bracket. Okay, that was good. Okay, now let's do the radical graph of this. Okay, what do we know about the x-intercepts? What do we know about the x-intercepts between the parent graph and the radical graph? We did it on the other sheet. What did we say? We said that the invariant points are going to occur when y values are 0 and when y values are 1. So if y values are 0, we know that these points here are going to be on my radical graph. So do I have to solve them again?
No.
Hopefully not. Okay. What about my y-intercept? Root 2. So is that going to be greater than or less than 2? Less than. I'm going to connect these dots. Will I go past my x-intercepts?
No.
Why?
Can't have negative.
Can't have negative y values. So I will have no arrows continuing on. So do you see how a sketch of this graph can really help you answer a very simple domain and range question that looks pretty ugly?
Yes.
Okay, x-intercepts being the key here. Okay, so domain and range of the radical graph. Domain. Negative 2 to positive 2.
That's what that is.
The range. 0 to root 2. Because it's your y values. Okie dokie, smokies. Yes, ma'am.
The first one, the.
Block graph?
Yeah.
Yeah.
You have negative 2 and e.
No, that's a 0. Oh no, why you can't read my 0?
Then what is that?
Okay, don't judge, okay? You try to come up here and draw, they're zeros, they're x-intercepts.
There's down this
Oh,
slope.
this one's finished, yes.
Finish?
Great.
That's what I was thinking.
Finish.
Oh, I don't think-
They're zeros. Okay, no judging. How did I get them?
Yeah.
Well, I listened to people, and they told me. Some people use the quadratic formula to get them. To get the y's? Or this one? These ones? They're x-intercepts, so I know my y will be 0. Your x-intercept is where y value is 0. It happens. Okay. So, let's see if you guys can do this one. What am I going to have? First graph. It's a graph again. It opens up. Starts at 5. Starts square at 5.
On the y.
So here. Right? We know that this is 0, 5. Any x-intercepts?
No.
Any place that the graph will have a value of 1.
No.
Oh, at y value of 1, I guess that would be. We have surpassed. So will there be any invariant points between your original graph and your radical graph? No. Perfect. Okay. So what's the next one going to look like? I didn't even close my graph there.
2.2.
So 0 and root 5. Now, here's the thing. Is this graph, what's this graph going to look like in relation to this graph? Is it going to be, like, is the red graph going to be skinnier? Is the radical graph going to be skinnier? Or is it going to be wider? How would you figure that out? You have the tools in your noggin there. And you could do it, but how would you do it?
It's just, what, it's just X. Because if you square root one, then it takes away the square on the X.
No, you can't do that, that's what fitting style. That's not a fitting style, we'll have to put another animal attached to that fitting style. Completely different. No, you can't square root this independently of this. This would have to be, you treat them as a whole. Okay, and we know that this can't be factored because we have to be unfactorable. But what, how can I got this point, but how am I gonna graph the rest of it?
We'll table values.
Exactly, I'm going to go table of values to figure out where I should be. Now, let's do this. I'm gonna go back to my black marker for a second, and I'm gonna do a table of values for my f of x function. Just quickly, I'm gonna pick -2 and +2. I'm just getting some on the left-hand side of the vertex and some on the right-hand side of the vertex. What would I do with these? Sub it into my equation. 9 and 9. Do you guys feel smart yet? Perfect. So if I do the same table of values for my radical graph, I just square root those numbers. Oh, so glad I picked 2. I'd like to say I planned that, but I really didn't. So now, if I go the black dots, this point here is -2 and 9, and this one here is +2 and 9. Just doing rough sketches here, people. This is not perfect. So now, at -2, where am I? I'm here, +2. I'm at 3. So what kind of graph am I getting? It's much wider. This is how you know what kind of shape you're going to get, by actually using values. Did I use a lot of values? No, but it gave me those 2 points if I needed to label them on a graph. Right? If this was a graph question and I needed to label them, it gives me those 2 extra points. It also gives me the shape, the context, because really all we need was this. Okay, I think I'm supposed to do the domain range here? Okay. What's the domain and the range of the original function? -infinity, +infinity, range? 5 to infinity. Now for the other one, domain is going to be what? -infinity to +infinity. And ranges, square bracket, having a hard time writing here, √5. Well, hey, no judgment, okay? Okay. Does that make sense to everybody what we did there? Does that give you a skill set to graph something that you don't think you can graph? Yeah.
I have a question.
Yeah.
The second graph, how is it wider? Because isn't,
What do you mean? 'Cause it's
like, I don't know, I'm just confused with the shape. Like, I know it's not an accurate graph, it's just a sketch. Wouldn't the red graph be,
Because 3 is closer to 0.
No, but remember the height. My 2s will be the same, this won't be as high. So in order for it to get to 9, like at the same point here, it would have to be 81 on the original graph. So by the time we get to 9, we're going to be way over here. So it's going wider and then up.
okay.
What, I don't understand why my interpretive dance is less important than the graph.
We show them.
I like my interpretive dance better.
Because it comes smaller than I.
Okay. You guys good? Graph the square root of a function from a graph. Yeah. No equations given. No. The reason why I say no is because you may receive a graph in which you cannot create an equation. Maybe it's a cubic function and you're not familiar with graphing cubic functions yet. Chapter 3, you'll get real familiar with them.
Like, see how those 2 points are here?
Okay, so let's run through the steps. We are on page 3. What? What are we doing?
Minus 7.
Okay, I'm hearing things. Step 1, locate the invariant points on the original graph.
I didn't figure out.
So we're looking for where y is 0 and y is 1. So y is 0 here, and 1 is here. You with me so far here? So this would be -4, no, -4 and 0, and -3 and 1 on the original graph. Locate other key points on the original graph where values are greater than 1. Nah, this would be another point that I'd pick. Why would I pick that? Hello, Miss Buchanan. How are you? Good. How are you?
I'm wonderful.
Yeah. Are you observing?
I just, yeah, I'm a teacher.
Oh, welcome to the stars. Hey, we are the mathematically elite. You missed my trip for dance not too long ago.
We dance.
No, it was not a basic dance. It was a wide parabola graph. That's what it was.
See, I'm always here.
Okay. Oh. Okay, so I picked this, well, I didn't pick this point. Evan picked this point at 0, 4. Why did he pick this point?
Okay, what's the one?
Because you can root 4 nice and easy, right? Because we only root the y values. Okay, so now I'm just going to do those points. This is an invariant point. This is an invariant point. This point now becomes 0, 2. Okay, now here's the deal. If we were actually to pick points in between the two invariant ones, where it's 0 and 1 for the y values, you would notice that this comes up slightly above that straight line. It comes up just slightly above it. Now we could prove this mathematically, or you can trust me. I'm going to tell you right now, this is a spot, if your line does not come up above the straight line, it's like a deduction of a half mark always. It's not even on there. When I'm going through the marking guides, I can show you. This would be an incorrect shape of the graph, and this is the key point that they're looking for. That you know that between here and here, this green line is going to slightly come up above the blue line. What?
Incorrect shape of graph.
There you go, incorrect shape of graph, always. Okay, so then a graph, that's pretty easy. All right, let's do the next one. Holy smokes, I think we might, I like this lesson better than yesterday's lesson. Yeah, you know, graph.
Yeah, you don't like the lesson.
I like this.
What? I said I like this one better than yesterday. I didn't say I didn't like yesterday. I like this one just a little bit better. We made it. Okay, let's go. Invariant points stay the same. And where it's 1, so zeros and ones. And then what's going to happen at this point here? It's going to go down to 2. But notice that it's not right on the, right? So that's going to be 2 over there.
Whoa.
Whoa, what?
Shit.
It's boss.
Okay, how are we figuring this?
I'm proud of her. You guys doing it. Imagine that goes through.
Okay, are those,
They have to be curved. This line should come up above the blue line a little bit here. Which mine doesn't, mine came up really good. No judging, okay? A little higher up here. How she get that what point? The last one, so I picked 4, right? Because we know the square root of 4 is 2. So that point I would say was like 3.2. So now it's going to be 3.2 and 2. Right? Okay, let's do the domain and range for this one. Okay, if you're going to talk about me in the third person and not ask me questions and then point fingers at me, friend, out the window you go. Domain, 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 domain. You could do the special one with the gap, or you can do an exclusion statement. Oh no. Oh, we'll do a unison one. We'll do a unison one, because that sounds like fun. Okay, but we have to make an assumption. Normally I'd make you calculate what the x-intercepts are. But can we just assume that it's 1.5 just so we can get the activity of the domain? So I have negative infinity to negative 1.5 including. Right?
Yes.
In unison with positive 1.5 to positive infinity.
That's from chapter 9 or chapter 8.
Yeah, it's one of those ones. Right? So you're saying that these two things happen on the domain, but you're showing that there's a gap. So you're saying this happens together in unison with happening at the same time. Range. Do I need to do 2 parts for the range? No, because they're the same on both sides. So range is going to be 0, positive infinity.
Yeah, I'm confused with this.
Okay, what are you confused about?
There's a gap.
We have no values in between here and here. The graph does not exist right there. Why? Because what's on my y values? They're all negative. And we know that we can't have a radical graph where y values are negative. What?
So you were just saying that it's like both sides.
So an absolute value graph, like the basic one looks like that.
Yeah.
Right? So you would end up with something, the same sort of thing, starting at 0, 0, and it would look like that. But it would be a continuous one because it shares the point 0, 0.
Okay.
Right? All your y values are positive. But you have a different shape. Your radical graph would be a curved line, your absolute values are straight lines. Okay, that's it.
So can we do this